everybody. Yes, my name is Meg, and I'm a user experience researcher for Google Cloud. And I'll start by just telling you a little bit about me and the products I work on. So I've been working on Google Cloud for a little over 3 years now. And for about half that time, I've been working on our Cloud AI and Industry Solutions team. And specifically, I've been working on what we call Vertex, which is our end-to-end platform for machine learning development. So all the way from training and building new models to deploying them and building your applications around them, we have services and a platform to help you do that. And I've been spending a lot of my time on explainable AI. So, and that's the topic of what I'm going to talk to you about today. So just to go into a little bit of the agenda for today, I'm going to go over the basics of explainable AI, what it is, what's the vocabulary in that space, what are some of the biggest techniques that you may have heard of. And actually in the chat, I would love to see, if you're somebody who's working on machine learning or you're interested or think you're going to start working on machine learning, if you put a little thing in the chat, I would love to know. Also, if you've tried to play with any of our Vertex services, I would love to know that too. But then after I sort of go into the basics of it, I'm going to talk about why is it important and what's hard about it. I'm going to tell you some stories from a past life. Before I worked at Google, I actually worked at a weather company. And that's a domain where you actually have to provide explanations for machine learning forecasts all the time to end users. And so I'll look into that. And then I'll provide sort of my recommendations for the UX of XAI if you get into that space. So just getting into the basics. Explainable AI in a nutshell is the endeavor to make machine learning more understandable to humans. And there might be some terms that you're familiar with. So a lot of times people will use terms like transparent or opaque, or another word for opaque. Sometimes people use the term black box. And that simply means, so transparent, one set of definitions for that would be it's a machine learning system that can reveal its internal mechanisms, and an opaque one is one that does not. This is a different set of definitions. So one way to think of a transparent machine learning model is that it's in and of itself, it can be understood by a human without anything extra. Whereas if it's a black box or opaque model, you would need extra services or extra post hoc techniques to sort of dive into how that model is behaving. For those of you who are familiar with different types of machine learning algorithms, there's certain types of algorithms that we generally think of as being transparent, and some others that we think of as being opaque. But one thing I want to call out is that those lines are actually a little bit blurred. So, for example, if you have a decision tree that's largely considered to be transparent, but if the decision tree is very deep or very complicated, it can sort of start to become more and more opaque. And on the flip side of that, you can have tree ensembles that are generally thought to be opaque, but if they're relatively simple, then maybe they're actually transparent. And so all of that to say is that the line between what counts as opaque and what counts as transparent is actually a little bit blurry. And then once you dive into the explainable AI area, there's all sorts of other terminology and terms. Some people use the word interpretable. In fact, if you go online, if you were doing some Google searching around this, sometimes the words interpretable and explainable get interchanged or swapped around. But this is a set of definitions that I like to go with. Interpretable AI is one that's where it's like passive characteristics. So if a human can understand it, therefore it's interpretable. So whereas explainability is more about those, the interface or the techniques or the services that you apply on top of a machine learning system to make it interpretable. And then there's this idea of comprehensibility, which is, let's say you have a machine learning model that you've developed over some set of data. if that model can actually represent to you something about what it's learned about the world, then that would be comprehensibility. And so now I'll talk about some of the techniques that are out there. There's a number of different ways that people have been thinking about developing explainable AI techniques. And I think I have them on this slide, but I think I'll just highlight some of the most popular ones. So I'll actually highlight this one in the middle called feature relevance explanation. On Vertex, we have a surface called feature attributions, which is this type of explainability technique. And actually, if you see on the right, there's a graph, and this is representing what's called Shapley values. And essentially, in your data, it shows you which features or how each feature contributed to the prediction score of your model. So whether it was highly relevant to the model or not. There's also a couple other ones that are pretty interesting. There's a technique called explanations by concept. And actually this image on the right is a specific technique called TCAV. And the idea is, let's say I define a concept like striped, and then I use the service, and you can ask a question like, how much does stripedness contribute to the prediction of whether this image is a zebra or not? And you can sort of see that having stripes in the images actually contributes a lot to whether the model thinks it's a zebra or not. And then another service is called, or another type of technique is explanations by example. And actually on Vertex, we've just released to public preview. So sort of in that public, but not fully all the way, we're still making improvements to it. We have a new service called example-based explanations. And what that does is it can provide essentially approximate nearest neighbors for a piece of data you give it. So imagine that we have a model that we've trained to identify birds versus planes. Then I could sort of provide this image of a bird in silhouette, and I can say, hey, give me all the approximate nearest neighbors or the similar images according to my model. And we can see in this case that actually the similar images are these sort of airplanes in silhouette. And let's say our model mispredicted or misclassified this image of a bird. By using this explainability technique, we can sort of see why. Like, oh, because actually this bird image looks a whole lot like these plane images. So one action we could take from that is, well, maybe we need to get more images of birds on silhouette, because that's sort of an edge case our model needs more training data on in order to sort of learn that relationship. And when it comes to explainability techniques, there are some that are model agnostic. That means they can be applied to virtually any type of machine learning model. And then there's other techniques that are model specific. And that means exactly what you think it means, that it's sort of designed to work specifically with certain types of model architectures. The other thing about explainable AI is that it can provide explanations at different levels of granularity. So, and people talk about it in terms of local, cohort, and global. So a local explanation would be you just have a singular prediction on a singular piece of data, sort of like the red dot in this image, providing an explanation on that. Whereas a cohort explanation is sort of taking a data slice or a data subset and saying, you know, here, provide the explanations of how the model is behaving for this cohort of data. And a global explanation is more like an overall, how does explanation of how the model works in general. And why is explainability important? So there's a number of different reasons. This is a quote from a paper I really like, which is, the danger is creating and using decisions that are not justifiable, legitimate, or simply don't allow obtaining detailed explanations. And that's sort of the risk with machine learning, especially with these opaque models. There's sort of a worry that they're not making decisions in correct ways. And explainable AI allows you this sort of window into why it's doing what it's doing, and it allows you to sort of build that understanding. So in particular, when it comes to the development of machine learning systems, the whole machine learning development lifecycle, explainability is very important. So when it comes to troubleshooting, so if you've developed a model and there's certain error cases where the model is not providing the correct prediction or has misclassified something, using explainable AI is pretty important in order to be able to um, troubleshoot those cases. Also, it can be used for optimizing your data pipeline. So when that technique I mentioned where you have feature attributions and you can see which features really contributed to the model's output versus the ones that are not, you can use that to sort of trim down your data sets to only the features that really matter to your model. It's also incredibly important when it comes to bias and fairness. So if you have a model that's sort of underperforming for certain subsets, so let's say you have a model that's talking about whether certain patients should receive certain kinds of benefits or treatments in healthcare, if it's underperforming for a certain demographic, or like let's say it's underperforming for everyone who's 65 and older, then that's sort of a bias in the way our model is performing. And it could be because of simply the data that was provided at training time. But explainable AI really allows you to sort of understand how the model's performing on these different subsets, on these different cohorts, so you can identify whether those biases are there and you can figure out ways to address it. Also, just for the end user application, humans are just not likely to trust or adopt things that we don't understand. So explainable AI provides a mechanism for providing those explanations and allowing people to build trust and understanding in a system. And also sometimes you need the why in order to make a good decision and move forward. Sometimes the prediction in and of itself is not enough. You need a sort of explanation in order to go forward. And there's actually a really great article I found on Medium that sort of describes this, how you would use different explainability granularities or different techniques throughout the whole machine learning lifecycle. But there's a lot of things that makes XAI hard. But specifically what makes designing explainable AI hard? Well, it's the human element of everything. So in order for an explanation to be successful, then it means it needs to be usable for the given audience. And there's a lot of people who can interact with these systems. Depending on who the audience is, your explanation might need to account for different domain expertise, different cognitive abilities, and different contexts of use. Okay. I see a couple questions in the Q&A. So one is, explaining an unsupervised or reinforcement learning models are typically harder. How do you suggest we address that? Yes, unsupervised models are harder because you don't have that ground truth of the label or the classification when you at that training time. And that is inherently harder, and it makes it inherently hard to sort of even identify the error cases or what you need to sort of dive into. In conversations with folks, the example-based explanations can be one pathway into that, because it can show you sort of the similar neighbors or sort of the neighborhood of how the model is behaving, and you can sort of use that as like an analysis to dive into that specific group of model behavior. But it is inherently a hard problem to solve. And then there was another question of, how can the model explain biases if it's not aware of the various factors? In the example you provided about the over 65 age group, how would we know that if that age is not part of the data set? That's very true. And actually that's something that comes up when we talk about data privacy. some of that information might be stripped away from your data set because of privacy rules or regulations. However, in order to do this sort of like bias analysis, sometimes you need that data to be there so that you can conduct this analysis. So it is a discussion of sort of how do we store that, what could be potentially sensitive information, so that we can actually perform the assessments that on fairness and bias. And that is a critical factor that people are discussing now when it comes to regulations on AI and regulations around bias and fairness. So yes, like at some point you need to be able to obtain that information in order to identify it as a bias. So I wanted to dive in. Thank you for those questions, and please feel free to continue adding questions, and I'll try to address them as I go. But I did want to talk through one example of how you're going to have different audiences with different needs for a machine learning application. So I want you to pretend that we're talking about a digital pathology tool. So let's say that there is a pathologist and they've been working with a company and they've provided a tool that can, with ML imaging techniques, diagnose or identify certain cancers in images, and that we've developed this into a digital pathology tool that pathologists can use to help make those diagnoses with their patients. So when you consider that scenario, there's a lot of different people who are going to be interacting with that prediction and any explanations we provide. So in that domain, there's going to be auditors and regulators in that sort of healthcare industry. There's going to be the developers, operators, and engineers for the overall application who are going to be sort of on deck to do troubleshooting and everything else with the development of it. Then there's the data scientists themselves, the people who have built the model that's going into the application. And then we have the domain expert, that's the pathologist. So they are the experts at pathology, and they're going to be interacting with it. And then there's the consumer, there's the end user or the patient who's going to ultimately be receiving these diagnoses. And if you consider that scenario, with the machine learning and data scientists, they may be experts on machine learning, but they're probably not experts on pathology. So they might not have the ingrained knowledge of how that data has been collected, what that data represents, and that kind of thing. On the flip side of that, if you have the pathologist, they could very well be the expert on that data domain. They know what that data looks like. They know how it's been collected. They know how reliable it is. But they might not be an expert on machine learning and those types of techniques. And then, of course, the end user is not an expert at machine learning and probably not a pathologist and doesn't know that much about the data. But ultimately, they're going to have trust and understanding in this system too. And another point is so my background is in human-computer interaction. And one thing we talk about in the sort of academic space, it's a word we used a lot when I was in grad school, is there's this word socio-technical systems. And what that means is that when you're interacting with anything in the world, there's the social space, that's when humans interact with other humans. And then there's the technical space where humans interact with technology. And then there's systems where you're all sort of interacting with all of these things together. And this is an example of that type of system. You have the relationship between the end user and the technology, but you also have the relationship that's being brokered between the end user and the pathologist, their doctor. And that's sort of all of this is sort of contributing to how they feel about the system, how they trust the system, and what kind of decisions they're going to make going forward. There's a really great paper. So NIST is an organization, it's a standards organization, and they put out this article called 4 Principles of Explainable AI. And they had an analogy where they compared explainable AI to the way forensic scientists present information to juries. And there was actually a study that said that jurors, there's been many cases where jurors have misinterpreted information presented to them by these sort of domain experts, the forensic scientists. and that kind of information can be misleading, and there could be some confusion there, and that has implications. It has implications for the justice system. And so one of the principles that they put forward is that in order for explainable AI to be successful, it has to be meaningful. And meaningful means that someone in whatever expertise that they have can understand the meaning of what that prediction is and what it represents and have an accurate understanding. And one also interesting thing about all of these people in this scenario is that they're all human, and humans are subject to a lot of different cognitive biases. And there's a few that I find interesting and sort of interact with this machine learning and prediction space. One is called anchoring bias. So we are more likely to judge everything in relationship to the first thing we see. So if I tell you a t-shirt costs $50, and then later on you go to a store and you see that there's a different t-shirt and it costs $25, you're going to say to yourself, oh, this t-shirt's pretty cheap. And that's because your reference point is the first t-shirt I said the $50. Whereas if I had said $15 and you go to that store and you see the t-shirt that's $25, you would say, oh, that shirt's expensive, because we use whatever we see first as a reference point for how we judge all the other information around it. And that's a bias we have. There's also availability bias, which is we tend to think of the facts that we see and have right in front of us as representative of the whole world or the whole population. And so that is something. So if we've only interacted or we only seen certain types of scenarios, we sort of assume that's how the whole world operates. There can be corner cases or other demographics of behavior out there that we just don't have in our purview because we haven't experienced them. There's also one, I'm sure a lot of people are familiar with, confirmation bias. So if we see a prediction that is in line with what we think should be happening, then we're more likely to just trust it and move on with our lives. Whereas if we see something, a piece of information that goes against whatever our prior beliefs or what we thought would be true, then we're more likely to interrogate it and do more investigation around it. And all of this can lead to unjustified trust or mistrust or overtrust. So you can have a higher degree than what you should of trust in a system. You can also have unjustified mistrust of a system where you don't trust it as much, even though it actually has good accuracy or reliability. And there was actually a really cool study done, and this is from the quote in this box I have on the right, where they had two populations of people. They had data scientists and non-data scientists, and they presented them with machine learning model predictions with explanations, but they had two different types of explanations. One was a human readable sentence, like an English sentence, and one was like a mathematical formula. And both groups, both the data scientists and the non-data scientists, had higher degrees of trust in the machine learning system when the explanations were in a mathematical format. And so I think that's really interesting because it just goes to show that the way you interact or trust a system can be sort of manipulated by the form factor of those explanations, that the form factor of the explanation changes the way you feel or interact with a machine learning model. So that's really fascinating to me. And I'll say that I think I put all that out there about like how humans have all these biases and it's hard for them, like hard for us to make good decisions, and it's easy to manipulate with form factor. And that can be seem really daunting. So like this whole task of providing an explanation, it can make it seem like a sort of overwhelming challenge to how can anyone possibly leave with an accurate understanding of what the system is doing. But actually, I think that there's a little bit of workmanship in the interaction design of those systems that we can have really good results. And there's actually, throughout history, we've actually been explaining complex things for a long time. There's a lot of work behind this. And so I'm actually going to tell you a story of how I worked on what is essentially explanations, the design of explanations in a past life when I worked at a company called Weather Underground. So weather is an example of very complex system with complex data. There's a lot of machine learning behind the scenes of weather information, and yet we interact with this type of system and make decisions about our lives all the time. And when I worked at Weather Underground, we did a lot of work on this sort of information visualization of our product. And one time we had a problem. So I don't know if you've ever seen images like this, but every once in a while there'll be something like a hurricane, and you'll see these news images of like a meteorologist hanging out in a storm, and they look like they're being blown over. But like meanwhile, in the background, there's just like two guys going to play basketball, like it's no big deal. And it's sort of this criticism that was sort of thrown at the Weather Channel and other weather sites was, you guys are sensationalizing weather. Like you're just trying to get ratings and clicks. You're not accurately representing what the weather is, and that this is a problem. And in fact, at Weather Underground, we had some feedback where people said we were sensationalizing our radar maps. And that was really interesting. And so that they didn't really trust like how we were presenting things in the radar imagery. And one thing that's really interesting about radar is like as a type of complicated data is that, at least in the United States, all of the radar data that all the different weather sites have is pretty much the same. So we all get our radar data from the National Weather Service. So at airports and at different locations across the country, there's radar stations, and different sites can pull in that data. But the way that you visualize that data is dependent on the service. So there used to be a weather website called Intellicast, and this is like an old screenshot from AccuWeather, but this is the same storm. So they have access to the same radar data, but they've made different decisions about how to visualize it. And you can see that you could sort of walk away. If you didn't see these images side by side, you would sort of think they were different storms and that you would be experiencing different things if you were in one versus the other. This is a sort of graphic of what radar data looks like. So radar is measured in this measurement called dBz. It's actually logarithmic. Please don't ask me technical questions about how radar works. You can sort of roughly map it to inches per hour, so like how many inches of rain fall per hour. But I put this up here just because nothing about this is intuitive, the way that we get this data. I don't think anybody really has an intuitive understanding of what does 0.1 inches per hour feel like compared to 0.2 inches per hour. So presenting this information is sort of hard. But there are people who do have sort of ingrained experience of that data, and that's meteorologists. And when I worked at Weather Underground, we had a lot of meteorologists working with us. And when I started on this project, I started by sort of interviewing them about what the experience of the weather was at these different dBz rates and the different rain rates. So I did a bunch of interviews where I'd say, you know, what does a quarter of an inch of rain actually feel like? And meteorologists would give me qualitative explanations of what that data meant. So they'd say things like, that's a solid rain, but not a downpour. You'd want an umbrella, things like this. And I started on this project of then trying to line this up to our visual display of radar data. So then I would talk to customers and I would say things like, what do you think this rainstorm, this image of a rainstorm would feel like? And they would say things like, oh, if I was right in the middle of it, I wouldn't want to be outside. People would say things like, I'd bring my dogs inside, or I might be worried about my storm drains, these type of things. And so I sort of did this analysis of how meteorologists were describing what the raw data was and what the users were describing the visualizations were on top of that. And so we came to this realization that there's sort of a big jump in what you experience of the weather at a roughly 35 dBz and 55 dBz, and that's sort of lined up for what our end users would describe when they saw the greens change to yellow and when they saw the yellows change to reds in our visualization. And so we ended up changing our whole color palette, and you can sort of see how we then adjusted our color palette. So this is the newer color palette, and here's the same storm in the older color palette. And so we tried to adjust. Essentially, our color palettes in this scenario are the explanation for the forecast and the radar. And sort of going through this process, we were able to tweak what that looked like so that people walked away with more accurate understandings of what that weather was like. So I say all that to say that there's sort of this like workmanship of interaction design that can be applied to this problem, and coming out with what DBZ equals Dragon Ball Z, what consists of hail. Oh, the interesting thing about different types of weather things is this is one thing I really love about working at the weather companies. I learned a lot about the data and everything from the meteorologists. And one thing that's interesting about the weather is when rain falls, raindrops are actually flat like pancakes. And then when they come more like snow or hail or ice, that's when they start forming these ball shapes and different things. And radar can actually tell the different shapes. So that's how on radar maps they can tell you when it's rain versus snow versus, and wintry mix is literally when it's mixed. There's pancakes mixed with other shapes. So that's, I learned like so much about all of that stuff. So, and going back to how can a model, and I love the question about is there a right or wrong to the interpretation as a user, which one should I rely on? So that's a very interesting question. And the way we approach that in that particular study is that we did not want anyone to underestimate dangerous situations. We wanted people to have accurate representations of when something could become dangerous. So when I did those sort of qualitative analysis, I focused on when people needed to take sort of protective actions for their property or come inside from the weather, and making sure those were the moments that were the most accurate in terms of people's interpretation. But that's a good question, because I think part of the design of an explanation is being really clear about what kind of decisions you want people to accurately make as they exit that explanation, as they leave your website or leave whatever you're presenting to them. You want them to make good next decisions. So I think that's part of that. Good questions, everybody. So I'm going to talk a little bit about what I consider the sort of the UX of XAI and what people need to think about. And there's another really great quote, which is, the property of being an explanation is not a property of statements, it's an interaction. What counts as an explanation depends on what the user needs, what knowledge the user already has, and especially the user's goals. And so I sort of think of it as how, when we're talking about this design of an explanation, how can we better help users meet their goals, and how can we help them better make decisions? And so when it comes to decision making in particular, I don't know if any of you have read this book, Thinking Fast and Slow. I really highly recommend it. It talks about how humans make different types, that we have different types of frameworks for how we make decisions depending on what scenario we find ourselves in. And so, and people think about, like, there's sort of the systematic, very in-depth interrogation, but that takes a long time. And then there's also the sort of like quick judgments that we make based on heuristics when we have to move fast. And there's this paper called Designing Theory-Driven User-Centric Explainable AI, where they sort of line up how people actually make decisions. So all the science about how people make decisions, and they map it to explainable AI techniques. So, and then they also have the biases. So there's like availability bias, anchoring bias, confirmation bias, and then they sort of map that to different ways explainable AI can mitigate that. And I think this is um, a really great way to think through, once you've identified the type of decisions somebody's going to make with your system and what kind of state they're going to be in, what kind of mechanisms or frameworks they're going to be using to make those decisions. You can sort of map that to what's available to us in terms of explainability techniques. And this is just another graphic from that same paper, where here we have all the different biases and sort of the description of them. And then there are techniques for overcoming them. And this is the XAI strategies we have to map back to that. So I think this would be a useful tool through thinking through that. And then also another key component of that, though, is I think we shouldn't lose the word interaction. So how can we build understanding through interaction? The research side of Google has developed a few tools that people that have explainability sort of as part of them. And one of them is called the what if tool. And there's another tool that's the sort of successor to that one called the language interpretability tool. I highly recommend you look into them. But the what if tool has this sort of interesting interactive component where you have all the features in your data and you have your predictions, and you can sort of play with those feature values and sort of find out when the prediction changes as you change different feature values. So it allows you to sort of interrogate your model in this sort of what if scenario. Like, what if, so imagine if you're developing a banking application and it's going to approve or deny home loans. You can change things like, well, what if this person's credit score went from 750 to 700? Would that change anything? And you could sort of mess with all these values and see where the boundaries are for different predictions or different classifications. There's also this really interesting paper where they use the example-based explainability technique as well as that sort of editing technique to do this great visualization where you can provide an input. You can see a distribution of the nearest neighbors, but then you can also sort of edit that image and sort of see how it changes. So in this one, we have someone did a doodle of an onion, and you can see all the nearest neighbors look very similar and they're all classified as onions. But if you start to erase that sort of circly bit in the middle, you can see that it starts to misclassify things or show you neighbors that have a classification of blueberry, and it sort of shows you. And then towards the bottom, just a single circle is getting classified more as a blueberry. And it sort of clues you in that if you can sort of play with the input in these sort of meaningful ways, you can sort of see, okay, the model is picking up on this sort of swirly bit in the middle. That is what's integral to identifying this correctly as an onion. And so it can help you find sort of error cases. It can help you find where the model is going wrong, and just overall build an understanding of what signals your model is latching onto in order to make those predictions. And I have another quote. There's so many great papers out there. But this is from the same paper that presented this editing tool I just described. And I'll just sort of highlight the last part where they talk about users can discover or ask questions about the limitations of the data, but doing so doesn't damage trust. It can actually play an important role in building it. So I wanted to highlight that when you have this ability to interact with things and play with things, it allows you to build a trust and understanding of the system that's very important. And I just have a couple more slides, but so interaction, explainable AI is going to be this interaction, and interaction design is a cycle. So when I was describing everything I went through with the Weather Channel and sort of redesigning the radar palettes, we have to go through that cycle of putting something out in the world, evaluating how it does, ideating on what could be improved, testing it out, and going through the whole cycle again. And so I think there should just sort of be a healthy understanding that when you're trying to put out good explanations for technical systems, that you're going to have to go through that cycle a few times. And when it comes to the evaluation piece, there's already out there in the world sort of best practice on how to measure the sort of user-centric aspect of it. So understandability, satisfaction, utility, trustworthiness, there's sort of published scales for how you measure all of these things. And this is my last slide, and this is a, excuse me, there's a diagram of what the machine learning life cycle looks like, from data collection, defining the task, testing and evaluating. And I have this here, like, when should UX get involved in the machine learning development? Well, I think it's sort of everywhere. So sort of defining what the actual goal is, evaluating it, prototyping it, testing it. I think the sort of interaction design and being iterative in your testing is sort of important throughout the whole thing. Okay, so that's it for all my slides. I feel like that was a whirlwind presentation. And I have to tell you, it's really a joy to be able to nerd out in this space and do this work. And thank you for all the questions. And I look forward to talking to you more about it.
Yeah, it's definitely a whirlwind. We've had some speakers in the past, talk about AI ML, and we have some guys that I know who for sure are in the AI ML space, joining us tonight. But just seeing this other half, the UX design kind of perspective onto it, just I don't know, not necessarily mind blowing, but kind of mind expanding. Oh, you really you really can apply these things, and probably should apply these things to the model to make sure that there's no bias, or at least know what the biases are. If you want that bias in there, or whatever, all the other attributes that your model might have, and just to be able to have that, unblack boxing the black box through having the explainability, was really really cool. And it's like a brand new topic. People might be deep into it, but it's a really really interesting topic.
Yeah, thank you for that. I think definitely having the sort of UX perspective earlier in the process can be helpful, because I see UX, like the role of it, as somebody who can help you de-risk and find all the considerations before you've actually built anything, before you've actually invested too heavily into a certain technical solution. To sort of think through and test those things before you even get there can sort of save you a lot of time up front.
Oh, that's great. Looks like we have one question in the main chat, and then maybe some more in the Q&A chat. So I'll do the one in the main chat. Maybe it's not a well thought out question, but what happens if successfully helping users make better decisions for themselves leads to reduced use of the product, like fewer clicks or refreshes? Like, you did such a good job that people don't have to keep coming back.
Well, I think that sort of has to do with like the business model of what product you're trying to put out there. But I would say, so if you help people make better decisions, if you have a product and whatever decisions they're trying to make, shopping decisions, whatever, then they are going to fall in love with that product. So maybe they don't have to use your product as much, but they're going to be developing brand loyalty. The more you help people, the more they're going to be loyal to your brand and keep coming back. And I think it's important to make sure your business model is not in the way of getting them. Like, you should design your business model around your customers being very successful from the get-go. That should be your measure. You should align the way that your revenue comes in with your user success, and that would be my advice there.
That's cool. Okay, on the Q&A chat, looks like we have. Okay, looks like you have a recruitment from Ramji. It looks like they're having an AI event at Capital One coming up later next year.
Cool. Sounds good.
I guess maybe look out for some messages from Ramji on that.
Sounds great.
And then slides and
materials. Can you recommend? Okay.
Yep.
Yeah, the slides, I'll try to publish them. I might have to figure out how to put them in like a PDF or something because but I'll try.
Yeah.
I'll do what I can.
Yeah,
Yeah.
if you send it in, if it's Google Slides, I can make a PDF, and I've been putting presenter slides on SlideShare, and then it links up. So we'll have the video SlideShare on the event page, so people have them side by side. Would that work?
Yeah, that sounds great. I can definitely do that because I do have a lot of links in here. There's just a lot of great resources. And of course, if you're using Google Cloud or you want to investigate those services, I link to all the documentation we have on that. So I would love to share that with you. And then for introducing school age kids to AI ML, that's a really great question. And that's actually, I don't have good answers for you right now, but I can tell you, like, I have a 9-year-old son, and he's very interested in technology in general, and I'm actually sort of searching for Christmas presents for him and things like that in this whole space. Certainly, there's a ton around Lego robotics that involves sort of smart decision making. It's not necessarily AI and ML, but yeah, that's a great question. I know that he's used things like code.org and different things. And I wonder if they have a machine learning section to that. And it also makes me wonder, in Google research, I know there's a whole area around education and technology education. And it makes me wonder if they have materials for that age group of kids. I'll do some digging. And if I find some links, I'll add it to the slides so that they can be shared.
Yeah, that'll be great. And if you find something even later, I guess in a couple weeks, send it to me, and I can email our group with some links if anybody's looking for them.
Awesome. That sounds good.
All right, looking through the chat, I think we covered all the questions in the chat, but I always have at least one question for presenters that's not technical. It's kind of a career help question, career guidance question, and it's if you could go back in time to when you were visit your 20-year-old self, what kind of career guidance would you give young Meg help her along the way?
What advice I would give. One thing that I have liked about my career is I actually made a lot of career decisions that had nothing to do with my career. Like, I moved around the country simply because I wanted to, and then I ended up moving back to the East Coast because that's where my family is, and so I sort of just like found jobs along the way, and I've been very fortuitous that this has just sort of worked out for me. So I think if I would tell my 20-year-old self, I would tell myself to just like chill out. Like, I think I thought you had to have like a 20-year plan to your life in order to be successful. And if you didn't, like, it wouldn't work out for you. But to have a sort of just to like make your decisions as you go and sort of to learn new things. Because one thing that's been very fantastic about that journey, and one thing I love the most about being in UX, is that I sort of developed this expertise on the human side of things, the interaction side of things. But in order for that to be useful, I have to like jump into a technical domain. So like when I was at the weather company, I had to learn all about meteorology in a way that I had never thought I would ever have to learn about. But it's just so much fun. And now I'm here at Google Cloud, and I never really knew that much about machine learning beforehand, but I've certainly had to jump in and learn about it now, and it's just a fascinating topic. So, yeah.
No, that's cool. Oh, I think I actually jumped over a question from Ramji. It was a few back in the Q&A chat. He says, I assume XAI needs to be built into the AI models itself, or do they need to be built in, or is it part of Vertex AI that Google Cloud has?
That's really good question. So certain techniques are you can use on any model, so it doesn't have to be built into the model. So for example, feature attributions, It happens completely outside the model. So if you already have a model in production today and you've never used any explainability with it, you can apply something like feature attributions to it, because essentially it just interacts with your model, like asking for predictions with the different permutations of features, and it builds up this representation. So that can be sort of applied post hoc. With example-based explanations, the way that works is it sort of develops almost like a secondary model at the same time that you develop your initial model. So that one, you have to be sort of aware that you're going to want example-based explanations at the time of your development of the model. So it really depends on the technique. So as far as Vertex services go, like everything under the feature attributions umbrella, which is for any type of data, you can use that at any time. We also have it built into we have AutoML, which is like automated machine learning development, and BQML, which is you can develop machine learning models from any data in BigQuery. Those, you sort of get feature attributions for free, like you can just sort of use that with it. But example-based explanations, you sort of have to do some forethought. So it just depends on what kind of technique you're interested in using.
All right, a couple more questions came in. One from
Kamala.
Yeah, like, is my eyesight working? Yeah, I think it's Kamala. And how do you recommend you approach research and design process when you're looking at healthcare? Like, how would you have doctors and end users early on, as when you have that map of all the different types of users, the personas that interact with it? Should they be there from the very beginning or close to the beginning, but maybe not the very, very beginning?
Yeah, definitely for those things that are, especially things like healthcare that are sensitive domains, it totally goes better when you have the experts in the room with you from the beginning. So having somebody, like if you were doing digital pathology, somebody who's like an expert of how that work gets done today will help you monumentally. And it also often pays to make them your ally. So there's a lot of things with digital pathology that we're not going to replace a pathologist. Like a pathologist has an expertise, but maybe we can make their lives better and easier. Like maybe we can make it so that they can do their work more efficiently. And so having those type of engagements early on, definitely I would bring them in from the beginning. From the HCI perspective, there's this term called participatory design, which is the idea of like you bring end users into your design team. They become part of your design team and sort of ideating different ideas and sort of evaluating them. And I would highly recommend that, especially for these fields where, I'm not a doctor, I'm not an expert at that practice. So being able to leverage them and bring them in is really a good decision if you can do it. Having end users involved too, that would be great. But sometimes there's things like sensitivities, you're talking about healthcare. It depends on the domain, if you can be able to do that.
Sure. And then maybe a quick one on the scale of 1 to 10.
How much does human psychology and sociology play in the UX? It's totally a 10. It's a 10 all the way to the top. It's everything. It's everything. So much of my job is like interviewing people. Even when I interview developers who use Google Cloud and I'm trying to develop tools, and there's so much about your prior knowledge, your prior experiences that influence how you interpret what you see on something new, and sort of like diving into that. And way in a past life, when I was in grad school, I worked on educational technologies. So I was learning about how do people learn, and that's come into play for everything. So there's so much about it. It's sort of integral to everything, but great question.
All right, and maybe one more. Maybe this will be the final one, because we're up to an hour. It's Richard Ratliff on the Q&A panel. What's the default feature attribution that you show?
E.g. SHAP. Yeah, so feature attributions. I am not the expert, but there's like different ways you can come up with the feature attributions. And one of those is Shapley values. Another one is called integrated gradients. I forget what the default is for Vertex services, but you can sort of choose. And we have like a sensible default. I forget what it is. Like if you don't have the time to do the research into the different ways of looking into that, we do have a sensible default, but you do get to choose. Essentially, these are just different algorithms, different ways, and some are more efficient in terms of how quickly they execute versus how accurate or robust they are. Like you can sort of play with those, but yeah. So I forget the default one, but maybe I can find the documentation. Yes.
No, that's fine. Let's see. Was there? Yep. Richard says thanks, and I'll say thanks as well. A big thank you. It's been glad you could join us and take time out of your busy schedule to talk to us about explainable AI. I still can't explain AI, but at least I know if I needed to explain AI.
Yeah, or at least now you have a friend, just like
yeah,
me.
not a friend.
Help you out. Sounds good. All right. Well, thank you so much, everybody.